Hi guys, this is Anmol Talwar and welcome back to another video with Talent Catalyst AI, where we strive to give you industry-specific artificial intelligence knowledge which will surely help you grow in your career ahead. With a work experience of over 7 years, I have handled projects related to natural language processing, artificial intelligence, machine learning, and generative AI across industries such as banking, pharmaceutical, financial, as well as marketing technology. So, let the learning begin. Topic for today's video is a fundamental topic in natural language processing, that is TF-IDF, namely Term Frequency Inverse Document Frequency. In this video, we'll be trying to define and introduce TF-IDF as a concept. We'll then be dividing TF-IDF into three subparts, that is term frequency, that is TF. The second one will be the inverse document frequency, that is IDF, and the third one would be the product of TF and IDF, which gives us a TF-IDF score. And at the end, we'll also discuss some of the limitations of TF-IDF, due to which we had to shift to deep neural networks or embedding based models for implementing natural language processing tasks efficiently. Let's try to understand what is TF-IDF. So TF-IDF is made of two words, that is term frequency and inverse document frequency. Now trying to decode what exactly these two mean. So term frequency, inverse document frequency is a methodology to convert natural text into a numerical matrix that can be consumed by a machine learning model for training purposes, since natural language text cannot be directly used as an input to any machine learning model. So how is TF-IDF different from other methodologies which create numerical matrix out of the text? A simple example of that is bag of words. How is it different from them? So the goal of TF-IDF is to quantify how important a particular word is within a document with respect to all the documents in that particular corpus. So we have two parts: the term frequency telling us how important that particular word is in that particular document, right? With respect to, the second part comes is with respect to all the documents in that particular corpus, right? Trying to understand this with an example. Let's say I, as a person, was given a task to write an essay, on myself. My name is Anmol Talwar and I were to write an essay on myself which should contain at least 100 lines or 100 sentences. So what I do is I write a essay containing 100 lines, 100 sentences, which is considered as the corpus, and each sentence in this corpus is a document, right? My task using TF-IDF is to gauge the importance of word I in the second document, correct? This is my task using TF-IDF. So I have the first sentence saying I am Anmol Talwar. The second sentence, I like to play table tennis and I also like to play with my dog. My dog's name is Rocky. The fourth sentence or the document over here is I have studied in Manipal Institute of Technology, and so on. I have many sentences ending with a sentence saying that I love my dog. Okay. Assuming there are many sentences in between which start with the word I, because that's a very common word. What happens is, if I were to find the importance of word I in document 2, it will give me the frequency. It will tell me that with respect to only document 2, since the frequency of this word is 2, that is relatively higher as compared to all the other words, because it is appearing two times in that particular document, the importance should be high. But what term frequency, inverse document frequency does is, the second part comes into the play, inverse document frequency, which what it does is it tries to get the importance of that word with respect to all the documents in that particular corpus. Now what happens is, it will go to the first document, it will see that it has I over here. It will go to the third document, it doesn't see that it has I. It will go to the fourth document, there is I. And in most of the documents, let's say of the 100 documents or the sentences that we have, let's say 60-70 of them have I word. So what it will judge is, that particular word is very common, it cannot be that important, correct? Since it is very common in the whole corpus, that each and every sentence mostly has the word I, it should not be that important. So this is how it differentiates between term frequency, wherein term frequency would have said that I is good, it has a relatively high frequency in that particular second document, the importance should be high. But inverse document frequency says that with combination with term frequency, saying that
since I is present in most of the documents, the importance won't be high. On the other hand, if I were to have a importance of the word dog in the second sentence, right, it would say, the term frequency would say that it has a low importance, not a very high importance word, because it's appearing once, only once, as compared to I, which was appearing twice. But when it compares along all the document, what it sees is dog only appears in 2 more documents. That is it. In total, there are only 3 documents in the whole corpus where dog appears. So saying that since this word is not so common, it might be a distinctive factor or an important word in characterizing who Anmol is, because this essay, the corpus, is based on who Anmol is. So this is the meaning of term frequency and also inverse document frequency. TF-IDF is commonly used in tasks such as text analysis, document similarity, and engine search ranking, basically in all the tasks that require natural language text to be converted into a numerical matrix that can be consumed by a machine learning model. Now, trying to implement term frequency, inverse document frequency mathematically, we'll first go through how to implement term frequency in the what is the mathematical implementation of term frequency. So term frequency, as we have already discussed, is a measure of how frequently a word or a term appears in the document. It also reflects the importance of that particular term in that particular document, right? In that specific document. Trying to understand this using a use case where we have a corpus containing 3 documents. That is, document 1, the cat sat on the mat. Document 2, the quick brown fox jumps over the lazy dog. The third document is the cat and the fox are friends. Our objective is to find the TF-IDF score for the word cat in the first document. So the document for us is document 1, that we have to, the specific document that we have to refer, and the word for which we need to calculate the TF-IDF score is cat. So as the definition says, term frequency is how frequently a term occurs in a particular document. The formula for that is number of times the term T appears in the document, right? The term T over here is cat, and the document D is doc1, right? And the denominator essentially is total number of terms in that particular document, that is document 1 for us. Calculating it mathematically, for document 1, the term frequency for cat is number of times cat appears in document 1 divided by the number of words in that particular document, that is document 1, the ratio of the 2, right? So how many times, what is the total number of words in document 1? Let's calculate. That is 1, 2, 3, 4, 5 and 6. We have 6 in the denominator, and how many times that particular word cat appears in that particular document? That is only once. So the numerator is 1. The term frequency over here is 1 divided by 6, that is 0.167, right? Now coming to the second part, that is mathematical implementation of inverse document frequency. As we have discussed, inverse document frequency measures how important a term is by considering how often it appears across all the documents in the corpus, that is relative importance of that particular word in the whole corpus with respect to all the documents, how frequently it occurs in all the documents of the corpus, right? In our particular use case, we need to calculate the inverse document frequency for the word cat, right? So to calculate that, we have the formula for IDF as logarithmic of the ratio of total number of documents in the corpus. Since we want it as a relative score with respect to all the documents in the corpus, to the number of documents containing the term T. How many of the documents in that particular corpus contain the term T, that is cat, right? So IDF becomes, in our particular use case, total logarithmic of the ratio of total number of documents in the corpus. How many documents we have in the corpus? We have 3, 1, 2 and 3 documents, divided by number of documents containing the word cat. We have 2 documents containing word cat, so it becomes logarithmic of 3 divided by 2. So the essence of inverse document frequency, as you might have got from the formula, is it's trying to calculate the ratio of total number of documents in that particular corpus and the number of documents containing the particular word for which we want to find the TF-IDF score. So that particular word, how often it appears in the documents, that is how it's calculating the relative importance of that word and its occurrence with respect to each of the document in that particular corpus. right? The more frequently that particular word appears in all the documents, the less importance IDF score will give it to it. That meaning, if a particular word appears more times in all the documents in a particular corpus, the IDF score will be less as compared to a word which occurs very less frequently as compared to the word which is coming too frequently, right? So we have the IDF score for cat as 0.4055. Coming to the third part, that is combining TF with IDF, that is term frequency score as well, and a score with respect to all the documents as well, right? We'll just, it's a simple multiplication, that is the term frequency of the cat in document 1 and the IDF score of the particular word that we have to calculate TF-IDF for, that is IDF for cat, the multiplication of these two, that is 0.166 into 0.4055, which we get as 0.068. Now the thing is how to interpret this particular score, right? Taking an example, let's say we were to calculate the TF-IDF score of word sat in the document 1, right? And let's say we have got a score for sat as 0.0005, whereas for cat we have a TF-IDF score of 0.06068. So it's evident that cat TF-IDF score is greater than the TF-IDF score of SAT. So TF-IDF scores with respect to a particular corpus are relative to each other, saying that cat as a word for that particular document is more important as compared to SAT as a word for that particular document. Since the score for TF-IDF for that particular document with respect to cat is greater than that of SAT for that particular document. This is how to interpret TF-IDF score which are relative to each other. Coming to the last part of the video, that is limitations of TF-IDF, why we had to move from TF-IDF to embedding based models, right? What were the limitations in TF-IDF that led us to move from TF-IDF to embedding based models, right? For specifically natural language processing tasks. The first one is there is no semantics in the TF-IDF methodology algorithm. The reason for that is it purely works on frequency, the term frequency, the frequency of the word. It is not able to comprehend the meaning, the inherent meaning of the word or the similarity between two words. For instance, for example, let's say bat as flying animal and bat as a sports equipment would have the same representation. If there were two sentences in a particular corpus containing, in one sentence bat was referenced as a animal, in the second sentence bat was referenced as a sports equipment, these two would have the same meaning with respect to TF-IDF, but these two are essentially different. Now coming to a second example of no semantics is, let's say there are two different documents containing words. First document contains cat and the second document contains kitten. These two words would have a different representation in TF-IDF, whereas these two words mean the same. So there is no semantics involved or the meaning of that particular word involved in TF-IDF because it works on frequency of the words, right? This is one of the major drawbacks of why embeddings were used later on instead of TF-IDF. Coming to the second limitation of TF-IDF is fixed vocabulary. Let's say we have these three documents with us that we discussed. That is the cat sat on the mat, the quick brown fox jumps over the lazy dog, and the third one is the cat and the fox are friends. Combined, let's say these three documents have a total vocabulary or total number of words as 20 different words, right? We have 20 different words in these three documents. Now, after creating the TF-IDF matrix, we send that particular TF-IDF matrix, use that matrix to train a particular machine learning model, saying that that particular machine learning model has been trained on a vocabulary of just 20 words. Since the TF-IDF matrix was composed of these 20 words, the model is also exposed to just these 20 words of vocabulary. Now, a scenario where we are exposing the model to out of time or unseen data, a data which was not seen by the model while it was training. Let's say the model encounters a word elephant. What happens then? What will happen is, since the model has not seen this word and since the model was only trained on the fixed vocabulary of 20 words, the model will not perform to the best of its capability because it has not seen this word because it is now exposed to unseen vocabulary which it has not been trained on. So this is one of the limitations of TF-IDF of having a fixed vocabulary because the matrix itself is confined to the number or the vocabulary that is present in the training corpus. Coming to the third problem of high dimensionality, right? As we saw over here, we only had, in this particular example, we had just 3 documents and we had 20 words. So 20 words, let's say we have the first word, second word, third word, fourth word, fifth word, and so on till 20 words. So coming to this particular example of 3 documents, since we have only 20 words, a matrix would look something, the numerical matrix would look something like this, wherein each word over here will have a numerical representation with respect to each document, right? We'll have that. But consider an example wherein instead of just 3 documents, we have, let's say, 100 and 1000 of documents. The number of words in that particular corpus containing 50,000 or 10,000 of documents, which is a real life scenario, the number of words will increase exponentially. Let's say the number of words increases to 1 lakh, right? We have 1 lakh columns because we have 1 lakh of unique words present in the whole corpus of data. Which what will happen in this particular scenario is the matrix will become high dimensional, and because of that we'll have challenges with respect to the memory storage and as well as computational expense. It will be the model or the data that is being fed to the model will become computationally expensive, right? This is the third problem or the limitation of our TF-IDF model. Coming to the last limitation of TF-IDF, that is sparsity. Coming to the same example where we have 3 documents and let's say this is how the representation is. We have the word the, cat, sat, mat, fox, brown, dog, correct? For in document 1, we have the word present. The is why we have demarcated it as 1. Cat is also present. We have demarcated it as 1. Sat present. Mat present. Fox not present. So we have a 0. Brown present. Not present. We have a 0. And dog not present. Coming to document 2, we have the present 1. Else we don't have cat, sat and mat are not present. 0, 0, 0. Fox, brown and dog present. We have 1, 1, 1. Dog 3 respectively. This is the matrix that we have got. So sparsity means the number of zeros present, right? Why does TF-IDF has more number of zeros present? Why is there a problem of sparsity? The reason is here we have just considered 3 documents. Let's say we had around 1,000 of documents, or let's say 10,000 documents, in which the total number of words this particular matrix would have become, like we discussed in high dimensionality, there would have been a total of 1 lakh words. This particular word at the end, let's say it was elephant, or the other word would be, let's say, animal, right? And many such words. We have 1 lakh of vocabulary, so we have many words wherein this particular document 1 will have all zeros. Document 2 will also have mostly all zeros because it has only these many words. Now document 3 will also have many zeros, right? Similarly, since we have 10,000 of documents, the 10,000 documents will have lot of zeros, very less ones. The reason is because most of the words are absent from any given document. Not all the documents, since we have a 1 lakh of vocabulary, not all the words will be present in all the documents. We'll have most of the words absent from all the documents, is why we'll have a lot of zeros and very less number of ones. This is what is called as sparsity. Since we have a high dimensional matrix and also there is a lot of sparsity, sparsity will not give any value add to the machine learning model training. This is why sparsity is not entertained that much, and that is why this is one of the limitations of TF-IDF specifically.
Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.